Hello, everyone. Welcome again. We're going to start in 5 minutes. So, in the meanwhile, I'm going to put some music. Thank you again. Hello, welcome again. Thank you for joining us for another live event of InMind Software. Today, we're going to talk about blockchain and delusion of trust. I'm here with our CEO, Omar Shandam. I'd like to start telling you about this promise of blockchain, of revolutionizing trust and removing middlemen, and change everything from finance to how we vote. But is blockchain truly as worthy as we live to believe? Now I'll leave you with Omar Sandon that here's gonna introduce you a little bit about this subject.
All right. Thank you, Gabby. Always a pleasure to be here and talk a little bit and share about our experience, not just working from the technical side, but also understanding how people react, how the business react, and how the business understand about blockchain and its intricacies. When we speak about security, trust, transparency. What are we talking about, right? So, um, I will try not to go into the rabbit hole of telling what is blockchain and how it works and why this and that. But other than that, just think sharing sharing about the key elements that usually the let's say the average Joe thinks when we speak about blockchain, and how those beliefs needs to be treated in a, I will say, responsible way, because otherwise it might end up into problems and trouble and not getting the real power and the real opportunity that this technology provides. um, so yeah, so when 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 we speak about blockchain as a something secure, let's try for a second that this kind of a black box that makes stuff happen. Not We don't know exactly how it happens, but well, we say that blockchain is secure. We say that blockchain is transparent. We say that blockchain allows a lot of use cases, and we went through those on our last live. By the way, I invite people to look at it if they want to know a bit more. But coming back to the topic of today, um, many times we hear, "Oh, blockchain is secure," and what 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 are we trying to say here is not just that it's secure because that black box solves the security topic, but is that the technology allows in a certain scenario and made in a certain way to have pretty much an almost infallible security, I will say. But here's the catch: it really depends on your use case. It really depends on how you are engaging into that. So without going into the deep technical knowledge, we have something that is called smart contracts that run on top of the blockchain. We heard about, well, there are immutable. There is something that is called a kind of an immutable ledger that will hold all the different transactions, and that we can see those transactions happening, and also that we can participate as transactions. I would say processors or builders. So in a way, what we are saying here is that we can we can allow we can be part of the network, we can support the network, and we can know what is happening behind scenes. So that's also a way of understanding blockchain security. It's not just that somebody solved it for me, like in a centralized system where, well, there is a database somewhere, there is some web server, and we might see some firewall in between or something like that. That is going to be solving the security. So it's not like, oh, I need to care about security. Somebody will solve it for me. in the blockchain field, it's a little bit different. Again, given the right context, the right scenario, and the responsible usage of the blockchain technology, I will have that security. But many times I need to understand how that works, because I'm an important participant of that security to be realized. um, so yeah, it comes from a different standpoint. So let's use a concrete example for the audience, to grasp it. um, Usually when I get into I will say my bank account, like I will go to my website or my mobile app, of the bank where I have some funds. And the only thing I need to care about is my user and password, right? And maybe a second factor authentication, which is very much recommended, especially in these days, to avoid any kind of hacking, or at least to make it tougher. So usually what I do is I get to my bank website, mobile. I enter my user, my password, my second factor authentication, and I don't know what is happening behind scenes. I don't know how it's being solved, but I know that somebody is authenticating, is ensuring that it's me, who is getting into the website because I have my credentials, and so security is solved somewhere else. My only participation in that security is ensuring that I'm not sharing my password, because otherwise I'm giving away the access to my bank account, and I could be doing transfer and stuff. When we have the same process on the blockchain field, I'm way more responsible of my own security. Why? Because there is no bank service that is holding my password, or that is giving me a way to recover my password if I forget it. There is something that is called the public and private key, that I'm the only holder of that, or at least I should be the only holder of that. So yes, blockchain are secure, but it's very important for me as a blockchain user, in a way of speaking, to be responsible in the way I handle my keys. So if somebody at some point created a wallet, they have seen that they are asked to write in a small paper, well, doesn't need to be small, but on a paper, like 12 or 24 words, which are going to be your private key. And they tell you, please don't take a picture of this, don't save this in any place that is connected to the internet or stuff like that. Why is that? Because anybody can own that. They will have access to your account. So now you are an important part of that security. So people would say, like, well, but you are saying the blockchain is secure, and it looks like, I need to be responsible of my own keys. Yes, it's very secure, and we can even say it's more secure than any bank access you may have, because um, there are other people that might have access to the bank database, or the user management, and perfectly they could be going and tampering the access, or removing your access, or impersonate you. It's technically possible. I'm not saying banks are going to do that, but I'm saying the security of any centralized system is as strong as the weaker the weaker link, and usually that could be the bank administrator, database administrator, system administrator. This is software. And so if I have access to that database, I could change the user, reset password, etc. On a blockchain environment, that's not possible, because if I hold my private and my public key, it doesn't matter if you are Ethereum founder, you won't have access to that. And why we know that? Because we have access to the open source of the code, of the how nodes are made, how they work, how they are connected, how they work together, and what happens behind scene, which is something also different regarding centralized system, where we
Yeah,
don't have how it's made. We don't have access to the code of that.
exactly.
So yeah, you wanna
Uh,
say? Yeah.
yes, I want to say that the point of failure, so it is the UX that is not so friendly for users. These the weakest links on the centralized partner. So the centralized size will be a point of failure. And you mentioned a little bit about the smart contracts. The smart contract is another point of failure, isn't it?
It is. It is. What usually happens is that we are the weakest link, and why is that? And you mentioned about the friction, the UX friction, and probably that's the weakest point. That's where problems start to happen, and this is from experience working with customers, trying to get into this blockchain world, especially when and everything is going up and everything is very excited. NFTs, everybody wants to do their NFT projects, stuff like that. It's not happening right now, but 2 years ago everybody wanted. So when that happens, you will start um, you will start discussing about specifics of the project, how the user is going to access it, how that ownership is going to work. And at some point you will be in the process of, well, how do we onboard users to this platform? Well, that works in this way. You need to ask the users to create their wallet. They will need to store their private key. They will need to enter these 12, 24 words and store it somewhere. And then they say, no, that's too much friction for my users. I need to make it easier. Well, that's the thing. If you start making it easier for them, it means that somebody is going to be managing that security for them. And many times we end up creating a private key management system that will have the worst of any centralized system, and providing full access to those wallets. So let's say let's grab Twitter as an example. Let's imagine now we are working on making well, X, not Twitter anymore, that we are making a decentralized X system, or not even decentralized concept, but ensuring that it's decentralized enough for me to ensure that I own my followers, and my followers own who they follow. So what we can achieve with a platform like that? Well, we can ensure that nobody is going to say one day, well, this account, I don't like it, it's not following our guidelines, so I will close it down, and you will lose access to your million followers, which could be huge. Because, well, that's what in fact might happen from time to time. You have Twitter followers, X followers, and in fact you don't have anything. It's X who has it, and they allow you to access through their platform. So in this X platform, that now I will have access, and I will kind of own my followers. Well, each follower will need to go through that wallet creation process. So if as the project owner, I suddenly say, well, that might be too much hassle for my users to go through. Let's try to lower the barrier, to lower the friction, and ensure they can still create a wallet, but let's manage the private key for them. you know and suddenly you have on your system, on your database, you have all those accesses, like, so in fact you are just making exactly the same process, because they don't own anything. Private key is not on their side, and you are making it available to anybody can hack that access on your centralized system. What you end up doing is the same system that is centralized, but way more complicated for nothing at the end. So you are same kind of X platform. You are providing exactly the same services, but you are just putting on the title, like you know on your followers, on your fandom, something like that. So um and usually when that happens, it's way worse than a regular hacking, because it's on chain, it's immutable, there is a lot that you won't be able to record that easily, because again, who owns those private keys, will manage it. So
Yeah,
yeah, those are kind of some of the examples where it's very, very, very important to understand what you are doing, if it makes sense,
of
if that
course,
friction is well managed, worth the effort or not.
of course. And so, for businesses that are thinking about some projects related to blockchain, for them is a good advice, like a critical thinking, um, like study very well if their business can fit to the blockchain, and if it is worth it, and yeah, about what you say about the example you made, because you maybe you end up putting stuff like a very complicated, uh, instead of easier the stuff for users.
Exactly, exactly. Well, they can ask us. They can ask us, and we can discuss. That's something we usually do to ensure. I mean, we don't like working on blockchain projects that doesn't take any advantage of blockchain, because that doesn't make sense, and at the end is going to be, it's not going to be successful, because it's just for the hype and just for the word. And well, in fact, having this, up and down, I think it helps at some point to clear the space, and allow the projects that make real sense, and get real value from using the blockchain. They stand out, and well, the other, they just die. um, so earlier you mentioned about smart contracts, and just small mention about what smart contracts are. There are little programs, let's say, or well, not, maybe not so little, but programs that works with this characteristic of being immutable, that being verifiable on chain. Like, you can actually, you can even see the code of what you are going to run. Anybody can try to run any function that smart contract is exposing, which is great, but also brings other challenges, because well, that program is there. I know there are some standards to have upgradable smart contracts, but if you like, you can have a smart contract that nobody is going to be able to change at all. So that brings great things, like, well, I can ensure that we will have an escrow contract that is implemented through a smart contract. So once we agree on the way we will be working together, that's going to be there, and nobody can change it, right? uh, but and which is good, because you can ensure, well, we are not going to cheat that, because you cannot change it. The bad thing is that, as it is, immutable, it's not just for the good thing. Also, the bad things, the mistakes, issues, bugs, they will remain there. So you start needing to think, um, in a way of, do I really, really, really need to have this function on a smart contract? Um, do I really, really need to store these on chain? Why? Because first, those are expensive databases. There are many layer one, two, and so on. For making cost of transactions less expensive, but still, it is always more expensive than managing any kind of database. So you always need to think on, well, if I store less, it's going to be better. It's going to be more scalable. It will be less places, or opportunities for mistakes, um, because those smart contracts are going to stay there, we can say, forever. So I always need to be sure that, well, risk has to be at the minimum possible, because we are humans, we make mistakes, we do programming errors. So we need to ensure by design that when we are solving something on chain, it needs to be as simple as possible. Less is way better in this case, because like, those transactions, they will remain there forever. Mistakes and issues always remain there for forever. So yeah, that's another very, very critical point, that
Yeah.
usually we just think, easily, let's we can solve in a smart contract. And one of the things, sorry, before jumping out, um, is the exposition. The smart contracts are there, and sometimes, if we think as a regular software development project, we might say, well, I can think on my smart contract maybe as the backend, or maybe as the way of impacting on the database. and usually that is behind some firewall. It's well protected, access are protected, and there is no such thing for smart contracts. They are publicly available. I want to see and access a smart contract. I can do it. They are public. I want to try to execute something. I can. There is nobody who can tell me no, you can try. So of course there are ways of ensuring that who can access and maybe, well, access, no, execute a specific endpoint has the permissions. So usually you say this particular wallet can execute this function. This particular wallet can do this and that. Usually what you see is reading. It's open for everybody. That's easy. But when it comes to writing, you need to be sure that you have the right wallet. You are part of the list that can be writing and executing to the smart contract. So sometimes you don't think on those cases, and you just leave it open because, yeah, I mean, who will access this? They need to know the contract address. They need to know what they are doing, what are the variables they need to pass. Yeah, but or everything is there. Everything is at your hand. It's at your disposal, so you will have access to that. You don't need a UX to access the smart contracts. And many exploits on NFT projects, and projects in general, blockchain based, they go directly to the smart contracts. They don't even go through any kind of UI. They just go and run the thing. And the other one related to smart contracts, it's about and this is a very good one, is the sequence. When you are running, um, usually you think on regular development, you think, well, this function is going to run sequentially, so I will run one step at a time. Well, we can think about multi-thread, but let's keep things simple. So, and nobody's going to mess with that. But what people doesn't think many times is that, oh, maybe I can start running a function, but maybe at the same time I'm also running another function. So maybe what you are thinking you are controlling, at some point somebody is just being faster and skipping it. And we have seen many exploits on that end too. So again, these are the kind of things you usually think when you have control of the platform, because you are the developer, you are the owner of the infrastructure of the servers, so you can define how people will access to this system, how they will access to this database, and so on. When it comes to smart contracts, once you deploy it, that's it. It will do exactly what you define to do, good things and bad things. So you always need to be extra careful. And again, ensuring that you are not putting on chain functions or storing stuff that you might not need to have there, because probably you are making more complex than expected and than needed, and it will leave room for error and exploits.
Very interesting what you're saying. And that leads us to another myth or dilemma, as you can say, about this stuff there. You were saying that everything on chain, we can see everything. That's about transparency. On this dilemma with anonymity, usability, about privacy concerns. Can you talk us about a little bit more about it?
Yeah, absolutely. A very good property of blockchain is that, in general, there are some protocols that work on that privacy item, but um, most likely all transactions are public, which means for the most simple transaction, that is, I'm sending a token from address B to C. I can go to the Explorer and I can see those transactions. I can see the registry of that transaction. I can see that B sent an X amount of the A token to C, which is great because it allows to say that transparently. If you have, I don't know, a donation platform that is based on blockchain, you can see where the money is going. If you are speaking that you are tracing all your, I don't know, crops process, you can see all that on chain. So it's not like you need to trust on what I'm saying. I used to use the example of free range chicken eggs, and that's the difference between what is advertised. Like you see the packaging says, those are free range chickens. So they are raised, in good places, nice. They have a good live in, and etc. And yeah, that's a nice, it's a nice packaging. But I need to trust on that. I need to believe you. Blockchain provides you a way where you don't need to believe that. You can verify that process if I give you the right tools. And again, instead of a fancy story, I provide you all the steps, because when the, I don't know, the farmer is picking up the egg, he registers that. When the distributor is picking up that egg, or analyzing this, or laboratory is bringing some information, they all feed that. So at some point, that supply chain, on chain, is so hard to fake that. Well, you can see all the steps, so I don't need to trust on that nice packaging. I just can verify it, and see what was the story behind that, and say, okay, this is pretty much legit. Um, the, the the thing there is that, well, again, everything remains public on the blockchain. So every time that it comes to, well, but I will be storing some information that should be private for other people. I don't want them to see it, because that might lead to the recipe of success. When it comes, again, let's take farming. When you are growing some specific, I don't know, plant, um, and you are storing all the process, what you are saying, or what you are giving away, is the different treatments you are giving, the different times you are waiting, when you are doing the cutting, where you are doing I don't know, whatever the process is. So again, here it's about having the right balance, and knowing what makes sense to store it, but also how do I provide tools to verify that. So it's not like I need to store the raw information. I gave this specific product. I did this at this time, but it's otherwise ensuring that you are fingerprinting that process, and ensuring that you are providing the right elements for somebody that wants to verify, to be sure that is getting, like if you say, I store in one place a file with all that process, that provides me a fingerprint that I will store on chain. And if somebody wants to verify that, you send the document, you send the fingerprint, and they can instantly, verify that document was definitely stored on chain. So you can trust that that document, provide all the process. So you are not giving away a recipe, you are not giving away users, you are not giving away anything specific, but you are still having proof that that happened, that process uh, went, or whatever.
That's perfect. I want to go back a little bit when we talk about trust myth, because we didn't talk about the 51% attack,
Oh yes,
um,
that's a good
and
topic.
that's another point of failure.
Well, yes, yes,
Or
it
could
is,
be.
it is, it is. The funny part is that that's the way blockchain works. And why is that? Yeah, it sounds like crazy. um, in any blockchain, in any public protocol, you have actors that are processing transactions. So again, you don't have a centralized server that is telling, here is the reality, here is the truth, here are the registries of this process. What you have is a network of different nodes, that's the name, that are telling what's the story, how the story was made, what are the different transactions that are conforming blocks, and they are piling one on top of the other, building the entire blockchain history, which is nothing else than, all the different things that happens over that system. If you have a regular database, that will be, your tables, your rows, that you are providing meaning somewhere else. So the way it works is that anybody can provide their I will say their, well, it's mining, but I don't want to get into the mining topic. But they can provide block generation, right? So that's exactly what happens. I want to be part of this network. I want to contribute to this network. I want to be able also to build blocks. So I will put my compute at service, um, and I will be part of the network. That's it. The thing is, most of the time people will do that because they want to be part of something in a positive way, and they will be rewarded for that if they achieve to build the next block. But at the same time, people with bad intentions, they can also be part of that because it's open, it's public, so I can also bring my compute power, but maybe I'm trying just to benefit myself. So when we talk about the 51% attack, what we have is, in an open and public blockchain protocol, you have bad actors that are trying to take over the network to tell their own truth. Because at the end, and each block, what is happening is the different nodes are saying, I do have the next block. The other node is saying, I also do have the next block. And at some point, they need to solve that. They need to say, okay, this is the only one and the true next block. So let's agree on that. Let's verify that. And now we all print that next block. And that's the way blockchain works all the time. The problem is when there is bad actors that come, and especially it happens when the network is still small. So it's very easy, to have, and this is more for proof of work, but might happen, with the different protocols and consensus protocols, with different words, let's say. But if you have more hash rate, than half of the network, well, you will be able to tell your own truth. And something I remember happened with some protocol is that, um, it was quite easy, to tell your own story by doing a 51% attack, and at some point undo that story. So what I did was, well, I'm sending these millions of this token. I'm sending that to an exchange. And the exchange is out of the network at some point, so the exchange will verify that that transaction is legit. It looks legit because it's coming from the blockchain. It's part of the story. That's it. It has been validated by majority, let's say. So yes, that those tokens are real. Perfect. He exchanged those tokens to another token from another network, nothing to do with the original one. And what he did was, now I will undo my story. So now I'm, you know erasing what happened. So now I have both amount. I still have the previous one, and I have converted to another token. Um, so yeah, the funny part of that is that's the proof of work working the way it is expected. The problem is, as you don't have enough network growth, and that's your weakest point right now, you should tell the other parties. In this particular case, you should tell the exchange, hey, you might need to be sure that your transactions confirmation threshold is big enough to ensure you don't have a problem. Because otherwise, it might be good business for somebody, a bad actor, to say their own story and then make it, like it never happened. um, so yeah, those are the kind of things that are interesting, from blockchain. uh,
Yeah.
Also, because otherwise they will think, well, blockchain is, it's not secure. It's like, this is software, and it has a way of working. Of course, when it comes to Ethereum, to the Bitcoin network, even others, like you grab the top 10, and it's pretty hard to say that, well, they have such a big amount of nodes validating, and many of them now, they're on top, they are layer 2, so they are on top of Ethereum, an example, or they are on top of Bitcoin. So that makes kind of very hard to break that history and make your own history. Particularly Bitcoin is like it's theoretically, I mean, it's could not be possible today. You should have so much hash power that is going to cost you more, um, to try to hack that, than
Mm.
anything else. So yeah,
Mm.
but small protocols, they don't have too much growth
Mm.
yet, and they don't rely security on somebody else that is already established as a network. Those are risks that you need to consider when getting on. So yeah, but at the end, that's the way it is. It's working the way it's expected to work.
Exactly. That's about the trilemma, isn't it? About security, decentralization, and scalability. That's the the trilemma. About this that we were talking about trust misconceptions versus accessibility and risk perception. What can you tell us about it?
Um, yeah, I mean, it's a little bit of everything that I've been talking about. Um, for me, it's the trade-off. The more security you want, and it happens in software in general, but particularly in blockchain, the more security you want, the harder it's going to be, the less scalable it's going to be. So having the right balance, it's what makes more sense. Ensuring that you're not using blockchain in a way that doesn't help you on your business need, you know and ideally you are coming the opposite way. Ideally you are not trying to do something with blockchain because it sounds nice, and might impress somebody, but it's more because you know that the pain you are trying to solve cannot be solved without blockchain. There is no other way. Why? Because, well, it's going to be hard for your users. It's going to be expensive. It's going to be hard to scale. And so it really, really needs, regardless of what anybody from any kind of protocol will say, that, well, you can scale here and there. Yes, but still, it's more expensive than having a centralized database. It's going to be slower than having a central database. That there is nothing. There is no way to beat it, right? You are winning from a different angle, and you are providing specifics and some characteristics that are very specific to some scenarios that we are still figuring out. We are still understanding, we are still discovering. There is a lot of technology that was made, that make a lot of sense in the lab, but when it comes to business, we are not yet there, at least in some cases. So yeah, what is more important is ensuring that you understand the pain you are solving, and then you realize, oh, blockchain, okay, I need this, I need that only I can only get from blockchain technology. Because then it's going to work, then it's going to make sense, then it's going to be valuable. Otherwise, it's painful. It's
Mm.
just painful.
Yeah.
So painful, hard to
So,
get.
summarizing a little bit, you were saying that businesses have to think very well if their app idea it fits into a app or a blockchain app, and then use some critical thinking and evaluate very well um if they need this solution into their into their into their applications. Another stuff we were talking about is that this technology is still evolving. We are in very early stages, so now we have like this new stuff in Ethereum about smart contracts and smart accounts also.
Yeah,
So
I think you're talking about account abstraction. And
abstraction, yeah, that's it.
yeah, and that's a way of understanding that somehow we need to provide options to the users. We need to ensure that, well, and understand this is tough to get. This is, there is friction So how can we overcome that friction? How we can make it easier for users to onboard? How we can embrace business use cases? So account abstraction, which is um, a standard that doesn't, it's not at protocol level. So it's a bunch of different smart contracts, and very specific architecture that somehow allows you to um, have users onboarding wallets without the hassle of topping that wallet, having any kind of gas pump system or something like that, and still having your users owning their private key and public key. So you didn't eliminate the fact that they still need to hold their private key, but now you eliminated the need for having tokens, to run transactions. So now they can still sign transactions, but somebody is sponsoring the gas of those transactions, which is already very good, particularly on Ethereum, that is, the biggest smart contract protocol out there. Some other platform, they have that kind of process at protocol level already, but here we are speaking about the most used blockchain. We can have another space more from a philosophical sense, on why the biggest, where, so on, etc. But yeah, without getting into that, I will say that this is the recognition that we need to make it easier, but at the same time keeping options. So it's again trade-off, because there are specifics. Somebody has to manage the account abstraction. You need to have somebody that is holding a system, or you can make it yourself, but it's not going to be that easy. So again, understanding the context, understanding where you are putting the risk level, and but at the same time how easy you are making it for your users. So there are many use cases that are easier to do now, with account abstraction. But still, I will not have, if I have funds, I will not have them through an account abstraction. I will still hold entirely, having my private key and public key management myself. But when it comes to maybe a business system where I need to ensure a business that is tracing all his process on chain, but I don't want them to be handling, tokens and stuff, where like an abstraction made a lot of sense. There are also easier ways when they lose the access, having a social recovery, stuff like that, that can be possible through the account abstraction. And at some point it's going to be at protocol level, but usually that takes time, like agreements, ensuring that we are doing things correctly, and etc.
Perfect. So we're finishing. I don't know if anyone have some questions. Let's see here in the comments if we can find anything. Later, if you can see this video, you can send us your question. We're more than happy to answer them. And also, if you want some free consultation, we're more than able. Here, Omar, he can guide you with all your ideas or question, inquiries you may have for your businesses. I don't know if you want to say something for this finishing, Omar.
Thank you as always, for hosting this space. And yeah, happy to engage with anybody that wants to understand how this works and if not might apply. This is something I really enjoy. Sometimes it's not nice, because first thing that I will tell is like, do you really need blockchain for this? Why do you need it? What makes you think you need it? But that's a way of understanding the real value, of using this technology, if it exists or not. So yeah, thank you, and happy to see if there is any comment afterwards. We will happily answer them, or you can reach out.
Exactly. Thank you. Thank you again for joining us. We're gonna announce the next live in the next week. Thank you. Bye bye.
Thank you.
Bye.